Alright, welcome to part C of our video. Part C reads, write but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y equals 1. So, we know that generally to find the volume of a solid, its volume equals pi times the integral of r squared dx. But in this case, since we're trying to omit s, it's going to be volume equals pi times the integral of big R squared minus little r squared. So, we're going to start this off by figuring out what our big R and our little r are. So, our big R is going to be from the top of the curve all the way down to the x-axis. So, let's start off by writing that. We know that again that our bounds are going to be from A to B. And I rewrote those for you guys. Okay, and so our big R is from the top of the curve e to the 2x minus x squared, and then all the way to the x-axis. But what we have to remember is that we're rotating around the horizontal line y equals 1, which means that we have to subtract 1 from this part of our big R because we don't want to include the area that's down here. All right, and we always have to remember to square it. Okay, and now we have to separate out our little r, which is going to be right here because that's the area that we don't want included in our integral. So that's going to be from 2 to 1 squared dx. All right, so what we've done here is we've taken out the s and we've taken out the area between y equals 1 and the x-axis, and this is what our integral is going to look like. Now that's going to be the answer because we don't have to evaluate it, so that's going to be all for part C. Now let's go back to closing remarks with Louis L'Hopital.